Well, happy to be here. I don't have the badge for happy to socialize, but I'm happy to socialize. So anyone, if you have questions, no worries. I speak a little bit Italian, so I capisco più che parlo. But I speak in Spanish too, and English, so just approach me at the end. So this is a pretty long title. Ensemble of GANs has a data augmentation technique for Alzheimer research, right? This is, we were going to be discussing why this is a long title, but I usually do like a couple of other slides to try to explain the whole topic of the talk. So we also can say that this is a talk about designing and developing your own capstone project. A capstone project is something like in between of an essay and a thesis, or not a thesis, like a paper, something like in between, not like completely official, but open. So yeah, this is like describing what was my process for creating the project. The other way of looking around this is using PyTorch to generate demented brains, which it's kind of weird, but also it's kind of poetic, right? Like using neural networks to generate brains. So I like this title. And what is the agenda? So we're going to be starting talking about Alzheimer, what is the motivation, and about the research in general. Also about the project itself, like what is the idea, what I was using for the project, how I come up with the idea, all that kind of stuff. The basis, an intro to deep learning if we need it. I don't know how many of you have been already working in machine learning. Oh, nice. Yeah, we can do a poll. Like how many of you have already trained a neural network or something like nice? Maybe like half? Nice, awesome. So maybe we can skip that part. I don't know. We'll see. Yeah, and this is, the project itself is like the combination of two papers. One is a Seagun paper, very famous paper, like one of the first one that started generating big images with GANs. And also a combination with another paper called Ensemble of GANs. And at the end, I'm going to be showing a little bit the solutions and the demo. The demo, of course, is not going to be live. We're not going to be standing here just seeing how the network is training. And yeah, at the end, just takeaways and what is ahead of us. A little bit about me. I was born in Venezuela, but I'm actually living in Chile now. But I work for a company in New York. So that's interesting. I have more than 10 years of experience as a software engineer. I'm an AI enthusiast, and very, very recently working kind of in a machine learning engineering. So that's kind of a mix between the two things I love very much. I live in Chile. I've been working in these three companies while living in Chile. I started to work at Groupon, Latam, but working with Chicago. I also worked in Ubiome. I don't know if someone knows what was Ubiome, and that's kind of blurry. That's why it's kind of blurry. But we can discuss that about the FBI raiding a company in the Valley and what is it called? Why is it called the smaller Theranos? But we can talk that later after the talk. And now I'm working at Elementus, which is a data analysis company for the blockchain. Of course, I'm not like a Bitcoin maximalist, so no worries. I'm not going to give you advice about blockchain or anything. We just work with the data. So we just analyze the data. We are not, we just try to catch the bad guys, basically. Working with cybercrime organizations in the US, and some law enforcement bodies from the US. I also love very much coffee and scuba diving. I'm a diver, and those are like 3 little pictures I wanted to post there. 2 days ago, I was diving at Liguria in Rio Maggiore, so that was pretty nice. So some souvenirs there. Okay, so let's start. So what is Alzheimer? Probably most of you already know what Alzheimer is. So Alzheimer is a disease. It's a neurodegenerative disease, which means that basically you lost your neurons. Your neurons are just dead. And that's why you see the difference there. The healthy brain is just like very completed, let's say. And the Alzheimer's brain have like holes. And those holes are just basically dead neurons. And those are actually holes, like your brain start dying. Well, some of the characteristics of this disease is like very difficult to diagnose a disease like this. Usually it's about behavior and not like someone just randomly getting an MRI just because they want it. And of course, there is no cure for Alzheimer. If Alzheimer happens, Alzheimer will happen. So that's why diagnosis is very important. And in terms of the issues about, the features or like the characteristics of the disease or the problem in terms of the research is that there is a data scarcity about the whole scene, right? So getting MRIs, images of brains from healthy people, and also for comparing that with people with Alzheimer is very hard. That's like the main problem. The other problem is privacy, right? So usually when you get a data set, you have to come up with, like apply for getting data set. There is a whole process of anonymization when you start, when you get the images from the patients have to be compliant with like all the rules of sharing the images, all of that. There is a sampling bias issue as well, because it is like a reduced data set. Basically, you will have sampling bias. Like one of the motivations was about art in some way, because a generator like this can be used in any forms, like for research, for hard research, or for awareness about the research. You could create like a website just generating art pieces with brains that are from like a generalized version of a set of people, which is kind of interesting, right? Another motivation for me personally is because my grandma suffered Alzheimer. So that's directly personal with me. We can talk about that later. But yeah, we can go to the capstone project. So what was, like, why I started this project is because I was doing the nano degrees programs from Udacity, which are like awesome, totally recommended. The deep learning nano degree and the machine learning nano degree in Udacity are kind of very popular now, but are awesome, so totally recommended. So one of those, the machine learning engineer nano degree, you need to create your own project and work in your own project, like from zero to completing everything, doing everything about the project. I knew I wanted to do something about Alzheimer, so I think like my obvious question was like, is there any data set about Alzheimer? So I wasn't sure. Of course, I started to look in Kaggle or any other databases. I found out about this issue with getting images from brains because there are like 3 or 4 data sets with MRIs, but are kind of hard to work with. Some of those are in 3D, not like in 2D, or are like different type of MRIs. But I found this data set. I don't know if you see it hit there, but it's an Alzheimer data set with 4 type of, 3 type of Alzheimer, and 1 is like the data set with healthy brains. So I found that, so okay, I have the data set, so now what I do, is there like a background research? Is there already some projects that have been working on this topic? And I found, I think it's not here, but I mentioned it here in that medical image synthesis for data augmentation. That was a project from NVIDIA, and they were using, I think was another type of images from humans. But they were using, basically they were using GANs for generating images in order to get like an augmented data set, right? And then, okay, I have like, now I know that some people are doing something like this, so maybe this is relevant. So now, is there any paper that I can mix or like use for doing this? Because if I do the same like NVIDIA, is like why I'm doing this? Maybe just because of the machine learning degree, but I wanted to do like something more. So I started to look. I actually just watching a video. Let's see if it start. I don't have connection, but I was watching. Probably many of you know Lex Friedman. He's like a YouTuber from MIT. Well, that's kind of weird, but he's like a very famous YouTuber in academia, let's say, and like all over the place. But he had a conversation with Ian Goodfellow, which was the creator of GANs. And in that conversation, he mentioned, like a very specific part of the conversation, he mentioned ensemble of GANs. He didn't mention like the word ensemble actually, but he was trying to convey the idea that if you, like every GAN that you train is like a very specific place in the distribution of the data that start generalizing that distribution. So if you train like hundreds or like whatever the number you train of GANs, those GANs, each of those GANs are going to learn particular points of the distribution of the data. So that was the whole idea. So I started to look about papers. I found that paper, and so I said, okay, this is it. And then the other important part is metrics. I needed to measure my results, right? Like there is no way that I create the project and just generate the image and that's it, right? I needed to also measure the project, and I found this. It was actually like competition in Kaggle it was called "I'm something of a painter myself," and they mentioned this score, FID score for PyTorch that we are going to be discussing later. But then with all of this, I have the whole project. That was like before even starting the project, I have all the ideas, right? First, going to get the data set, right? The data is the most important part. The data-centric approach of these days probably is the right one. Then I was researching for previous work and getting like inspired about those previous works. And then I wanted to do something kind of new and like a mix of different ideas. And then, of course, I needed a metric. So those are like kind of that was the process that I follow. Maybe not like the process, but this is just like how I did it. And that worked pretty well. So, okay, so now if let's go right deep into deep learning. I don't know how many of you have already trained something like a multi-layer perceptron. It's like the basics, the most basic neural network that you can do. But yeah, the simple idea is that you want to predict something. You have a data set. You want to learn from that data set, and you want to predict a value from whatever the data set you have. In this case, is trying to predict the house price, having the size of the house, right? So in this case, it's very simple. You have only one neuron, and that neuron is like a line trying to predict the price. If we go a little bit deeper, we can see that now we have more variables in the equation, right? Now we have the family size, walkability, school quality, wealth, all those values, right? And we can see that those values are connected between them, right? So now in this case, let's say this is a network of 4 neurons, and each neuron is just a function of like devising the next step on the network. and what will be the value, the final value, just the price of the, that will be the prediction, right? Having all those values as inputs. If we go further, we know that a neural network is not like you define which neurons are going to receive which values. You just input all the values in all the neurons, and the network should adjust in the like how it learns and establishes the values internally in each of the neurons, and then you get the price as a final output. Then if we want to see like how a neural network really works, this is one of my favorite visualizations. This is one from a YouTube channel that is called 3 Blue, 1 Brown. Probably some of you already know it. But this is how a network is classifying an image of a number, right? So the idea is that you have the image of the number, which is a matrix of pixel values between 0 and 1, which is like from black to white. And then you input all those pixels in the first layer. That is the idea. And then you pass through all the activation of those neurons through the network. And the network will be kind of like a river, putting rocks in a set of rivers, and then you will have a final answer, which is like activating the final neuron saying, okay, this is a 9. That is an encoding at the end that is telling you like if it's a 0, between 0 or 9, which is the value for that image. But that's like a very cool animation. You can see it like a brain working in real time. Now going a bit deeper, this is like kind of the basics on a classifier, what we call a classifier, right? So in a network, what the main goal is trying to predict a value, right? Trying to predict a number, trying to predict something, trying to classify something. But in this case, for supervised learning, for the case of supervised learning, because we are going to go to the GANs, for the case of supervised, we have an expected output. So that will be like your data set. Your data set is going to be the distribution of data that you're going to use for training your network. So then the network is going to learn about that data distribution, right? So that implies that you have data with correct values in this case. So you have like you start with random inputs, you pass through that into the model. You have an output, which will be like the prediction from the model, and you compare that output with the expected output that you already have, and then you calculate the error and adjust like what the model should be answer having that input, right? So that's the whole idea. You predict something, you compare with the expectation, you calculate the error, and you update the network. So that's the whole idea of the supervised learning. A GAN is a little bit different and a little bit complex. In this case, a GAN is unsupervised learning because you don't have like expected values for creating something. In this case, you are not predicting something. You are trying to learn to generalize the network in order to generate something that it looks like the network. So this is very different. So in this case, you can also see the blue boxes are actually two models. In this case, again, is like it's called adversarial network because these two models are competing. One is generating images, and the other is trying to classify if any of those images are fake or real, right? So the discriminator is just like the previous model we saw. So that blue box is just like how that discriminator works. It gets an image, and it tries to predict if that image is real or not. But the generator is a new thing, right? So that model is not like getting a value or an image and predicting a number. In this case, is getting noise, like random noise, and coming up with a whole new image that represents the data set of images you have. So the idea is that the generator creates images, and those images are sent to the discriminator. You also get images from the data set, and you send that to the discriminator. And the whole process for learning is that the discriminator, when you calculate the difference between what the discriminator predicts and what the data is coming, is because you know from where that data is coming. Like if you are receiving the data from the generator, you know that image is fake. So when the discriminator outputs something, you calculate the error knowing that the prediction should be 0. And when the discriminator gets the image from the data set, which are real images, we know it should be 1. So the difference should be 1 minus what the discriminator outputs, right? So now you can, with those values, you have the error to update the discriminator itself, and also you have the error adjustment for the generator itself. So you are basically training 2 neural networks at the same time with kind of the same data, right? So that's the DC GAN. This is how the GAN works, just like a quick picture, right? So you receive from the generator noise, and you go up, you are increasing. In each level of the network, you're increasing the data that you are generating, and at the end, you generate the image, and the discriminator backwards, right? You receive the image, and at the end, you just output a number. And yeah, so what is an ensemble of GANs? When I first saw this, I thought that, oh man, this is a very complex concept. But it's not, right? It sounds very cool, but it's very simple at the same time. So in this case, if you have like a set of models, like you have, I don't know, a decision tree, support vector machine for predicting some kind of value you are trying to predict, if each of those models are good in some particular way, the best way to create like an application for predicting something, a complete application, is just putting all the models in one place, sending the inputs to each of the models, and then calculate the means, and that is your final value. Like very simple, right? Like just adding the numbers and calculate the means. But of course, in this case, you have the outputs of those models is a prediction between 0 and 1. And calculating a mean between those is very simple, right? But how do you do that with images? So we're going to be discussing 3 techniques. The standard ensemble of GANs, self-ensemble of GANs, and cascade of GANs. Those are coming from the second paper I mentioned. And I think we can go just right to those and try to explain them. So basically the answer is at the end, but just trying to explain each of the GANs. So this is the first one. This is the self-ensemble. So the idea is that you take the train set, train a neural network, and then take a snapshot from, like you define like a number of epochs. I want to train this net for a number of epochs, and then I take a snapshot. Then I start from scratch another network and do the same. And then I start from scratch another network and do the same. So then you have multiple GANs from multiple distributions of the same data. And what you do at the end is just after having those GANs already trained, you, in inference time, so in the moment when you want to generate the images, you just pick one of those models at random, and that's it. So that's the whole idea of the ensemble. You have maybe 100 models, and you pick one and generate an image, and the next time you generate another image, you pick another one, just randomly. Very simple, right? The only thing that changes is how you train those models. This is the second technique, which is called self-ensemble. And this self-ensemble is you take a snapshot of the model at a certain epoch, and then you keep training the same model and take another snapshot in another epoch further in time, and then you go and do the same all over again. And in this case, at the end, you do the same. You want to generate an image, you pick one at random and generate the image with that model. And then the third one is the most complicated and probably the worst because it doesn't work very much. But the Cascade of GANs, what you do is you take the whole data set in the first one, you train it for a certain amount of epochs, and then you get all the images from the train set and pass it through the discriminator of that GAN. And in that case, you build like a gate. So then for all of the images that the discriminator is saying are real, for you pick a number like a threshold. Let's say 80% of the images that have a bad prediction, those images are going to be used for training in the second model. So that means that the discriminator should know that those images are real, right? Because are coming from the training set. But for some reason, because of the probabilistic nature of the GAN, for some reason is classifying those as fake. Those should be used for another model. And you do the same, and at the end, you apply the same, basically, in the inference time. You pick one at random and generate the image. And then let's go to the demo. I think we have a little bit of time. We're just showing the demo. I think I can show. This is the most important part. This doesn't matter. All these notebooks are in the repo, so you can inspect it. But the most important part are the ensembles, right? And the model. I created like a base model. This is a base like a normal DC GAN, no ensemble, just one model. And you can see it at the end. This is just me inspecting the data and all of that. And here at the end, well, you have the loss values for the generator and the discriminator, and you see the random length of the GAN just fluctuating all through, but going down. And then at the end, you see how it's generating. I was at the end. But then you see in epoch 1, it's just noise, right? And then when it starts generating the brains, you start seeing something appearing, right, in the image, something more. Something weird that you see is like gray matter, where it should be black, right? So that's just noise. But if we jump into the last images, this is a lot of epochs. If we go to the last images, these are like kind of the last images generated by the GAN. And you can see this looks like a real brain. If we go into the last example, this is the Seagun, and I go here just to show how bad the Seagun is. These are examples from the Seagun, and in this case are kind of weird. And at the end there is some noise, and I put some note there about the noise. You can see there is like noise in the black part of the image, which shouldn't be. No time. Yeah, roll up. Yeah, and then at the end, just some takeaways. So about what are the conclusions, right? So if you read the notebooks, you will see like one of the best techniques in ensemble is self-ensemble. The Seagun is not very good for this kind of studies, but you can see a trend in these kind of ideas, and this is this is like the most advanced example of using GANs or generative AI for creating brains. In this case, they are using latent diffusion models, which is used in Stable Diffusion or Midjourney V5 these days, right? And what they are doing those are not 2D images. Those are 3D images. They are generating voxels, which are like 3D cubes, basically like cubes of images, of MRI images. And in this case, it's very impressive, right? It made me feel old about the research I was doing. I put some resources in the slide, and I think that's it. Grazie. Sorry for so much time.
Okay, so thank you. Raul, I think we have time for only one question based on Slido. And the question is,
I think it's off.
it's off, sorry. The question is, for evaluation, did you try to look at the performance of a classifier trained on generated data, but evaluated on real ones, so not created by the generator?
Well, so in the training, you basically train a classifier there. But yes, in the chat with Lex, Ian Goodfellow mentioned something that is very interesting. So what you do is you create the ensemble of GANs. Then after creating it, you generate images with the ensemble, and then you train a classifier using the fake images, and then compare that classifier with another classifier trained on only the training set. So that means that maybe the classifier that was trained with the fake data is going to perform better than the other one, just because the fake data is like a generalization of different points in space of that distribution, which is very interesting. But I'm not so sure if that answered the question. Any other questions?
Okay, just quickly, because there is really no time. I do have a... Yeah, okay, no, we don't have time. We'll talk about it later.
All right.
Okay. So thank you, Raul. And
Thanks so much for having me.
thank you, everyone. Okay.